intent classification, and simultaneously we want to create name entity recognition. So if you use multitasking, we can simultaneously achieve both of them. And name entity recognition, for example, person, we call it PER, so it's different tags. It's just a review. For example, the name Washington could be a person, could be organization, could be location, could be geopolitical, and vehicle, or anything else. So it's name entity. And biotagging is just, for example, for begin, we use B. For internal, we use I. For O, it stands for out. For example, I location. It means internal. It's internal. Or here, it is the beginning of the word. And by multitasking, as I said, you can achieve both of these goals: entity recognition and intent classification. And we have two tasks, NER and intent classification. So using these shared layers of neural networks, you can use, so it's kind of multitasking. And multitasking is just one of the ways for transfer learning. Of course, because name entity recognition and intent classification are similar, you can somehow use this kind of progressive learning. And so evolution of NER, we don't care about traditions, statistical, conditional random fields has a beautiful mathematical background. That's why we even use it here in our modern neural networks. So we have a length of a sequence, and for example x, and then we sum over all feature functions. We have different feature functions, and we have the weights of that. And so we have some observation like hidden Markov model. It's very similar. We are using conditional random field here. So the goal is just to maximize this, and we know the derivative, and just use any gradient descent algorithm, and that's it. For example, if I say Farshad is cycling in the jungle, this is the person, and it outputs this. Jungle is a location, Farshad is my name. And BioLSTM is an approach, is a modern approach. So here we give it to BioLSTM, and it provides these entities, and it recognizes these entities. You could use BERT as well. So any architecture that you like. And I used Connell 2003 data, so it's very popular. Many people use it. And it is in Hugging Face. And as you see, this library, it provides, if you go to the Hugging Face website, you will notice this. You can read about it as well. So, for example, I want to say that here, first you upload your dataset. Of course, by coding, you can put it on your Google Colab. So you have training data, validation data, and test data. But two of them are enough. You can, and then so we have some tokens, and here we can see the name entity recognition. For example, 3 is here. For example, 3 is I person. 4 is B organization and location, and miscellaneous. It means nationality or any other thing. And so if you open that text file, you will notice that 9, for example, it has 1, 2, 3, 4, 5, 6, 7, 8, and including this point dot at the end of the sentence, so it is 9 points. And 3, what is 3? 3 means check it, it's person, it's internal, and the same thing. So you got the idea. And you have many other samples for your training. And the transformer block, I use I inherit from layer, and here I use the dropout. And for token and position embedding, we use these codes. You can see in my GitHub repository, the second project is here, and NER model using transformer. So number of tags is just the length of your mappings. So we first tokenize and do position embedding to get, and then we use transformer block, and after that you give it to dropout and a dense layer, and this is your transformer. So we use the transformer for name entity recognition. So as I said, this is important. The length of mapping is number of tags, and our vocabulary size is 20,000. And we use the inference here at this line, prediction, because we are maximizing. Now we have trained, and now we can do it for a test point, and so we can see what it predicts, what is the text that it predicts. And for example, it says that for Farshad lives in Germany. Farshad, here it doesn't know my name because it is not in the text. It hasn't learned that. But Germany, it uses EU, Germany, and those things in the text. So it has trained on the word Germany. So that's why it understands that it's a location, and it's usually in the beginning most of the time with high probability is in the beginning. And so for intent classification, which is another thing that you want to do in order to create your virtual personal assistant, you have lots of sentences, and we want to know the intent of that. For example, flight book. For example, cancel booking. Hi, Samantha, please cancel my booking. And then Samantha understands that it is cancel booking job. And so intent classification, this is a good paper. You can read and enjoy that. And you can use BERT because transformers are faster than LSTM. LSTM has lots of problems. That's why in Google Brain and even in DeepMind and in many companies, they don't use recurrent neural networks very much because it is not scalable. You know, if you use transformer, you can do, because matrix multiplication and those things like, for example, dilated convolution, all of them are just multiplication of matrices which our computers are very good at. So we give our words here to the transformer, and it understands the intent of that. And you know that we have BERT base, which has only 12 encoders, but BERT large has 24 encoders. And by the way, this is 340 million parameters. Our brain has 100 billion. So you can increase, no problem. You can increase the size of these things. But we don't use all of our neurons in our brains. So that's why I hesitate to say that we can add even more, because we use maybe 5% of our brain, and so it should be something else. Maybe we have not understood our brains. So, and the bird, in pre-training we use mask language modeling. There are two jobs. The next one is NSP, next sentence prediction. You give a sentence, you give another sentence, it should understand if this is if it is the next sentence. And after that, you have fine-tuning, and you understand that if, for example, in question answering, you give question, and then you give the paragraph that has a sentence, and you say that, oh, here is the beginning. So beginning token, and it learns that. And, embedding is composed of token embedding, segment embedding, and position embedding. Token embedding is just word to vec, and segment embedding, position, if, for example, this is prior to this, and so all of them are intuitive, but what is segment embedding? So sentence per classification. We judge whether two texts are semantically similar. So how can BERT distinguish a sentence pair from two sentences? For example, this is sentence 1, sentence 2. So we put 0 for sentence 1, 1, 2. So we add all of them, and BERT understands that how two sentences are related. We can, as I said, you provide question and the paragraph that you can find the answer in. And here you can say what is the start token, what is the end token. And you can use it for sentiment analysis in financial markets. For example, Elon Musk says something, you can see if the sentiment of that is good, it raises the market or not. And BERT for intent classification, which I will provide the code as well in my GitHub repository. And so when you say listen, it means play music. So all of these are the intent. And I like Richard Feynman very much. The first principle is that you must not fool yourself, and you are the easiest person to fool because you are inside of that. So you cannot understand if you are an ignorant or not. So Socrates says that we should be very careful, because we should know that we are ignorant. All of us in this world are ignorant. If we are aware that we are ignorant and we don't know lots of things and we are making decisions incorrectly, then we can improve, then we can learn, then we can accept all failures. We can grow because we have accepted that we are ignorant. So when I say I'm an ignorant, it means you are a great person. You have understood that you should learn. You should accept your mistakes and your failures. You should respect everybody because your knowledge is limited. So you should accept that you are ignorant. And this is a beautiful thing. And all physicists are humble and ignorant because they know that there are lots of things that we should know. We should know that all our motivations, all of them are biased. All of our decision makings are biased because we haven't learned everything. Our brain is limited, although it has 100 billion neurons, but it is using just 5% of that. We don't have a technology to use all of neurons of our brains. Maybe it becomes very hot inside our brains. But, for example, intelligence augmented is one of the ways to increase our capabilities. So combining human with an AI, it could make us better humans. But Richard Feynman also says that